So we've talked about how to calculate the theoretical or the ideal amount of product that we should get from a chemical reaction. And we also know that most chemical reactions we can actually perform in lab and mass products, or we can capture products if they're gases and mass them and figure out how much we get. Now, if we wanted to compare our theoretical or our ideal amount of product to what we actually get, we need something called percent yield. And it's used to determine, kind of in part, the success of an experiment. So in most cases, the more product you produce, the higher percent yield you have, the better your reaction went. However, under most conditions, a 60% yield is pretty good. Unless you're working with a reaction that goes really well every single time and doesn't need to be under a certain set of conditions, most reactions are good if you get about a 60% yield. So really what this does is it compares the ideal amount of product to the actual amount of product you get. So it's pretty simple to set up. Percent yield is simply your actual amount divided by your theoretical amount times 100, because it's a percent. So your actual amount is what you measure from an experiment. So our example is going to be reacting iron with copper sulfate. We got copper that we could mass at the end. That would be your actual amount, something that you physically measure. Your theoretical amount is what you calculate using the balanced reaction in the BCA table. So doing a stoichiometry type problem to calculate ideally how much copper you would get. So here's the whole example I've worked through. So our reaction of iron with copper sulfate gave us iron sulfate and solid copper. So if we set up our BCA table, we had excess iron. We had approximately 0.04 moles of iron sulfate that we put in and dissolved. It's all a 1-to-1 ratio. We're starting with 0 here, so we're going to lose 0.04 moles and gain 0.04 moles on the products. So we still have excess iron left over. We knew that. We had nails left over in our solution. And we had no copper sulfate. It was no longer blue, so that was all gone. We're going to assume that it was all used up. We have iron sulfate left over. That wasn't something that we could measure. That's still in solution. And we had copper, solid copper form, and we should have had 0.04 moles. 0.04 moles of copper, if you convert from moles to mass, comes out to be 2.54 grams of copper. So that would be our theoretical yield. Under perfect ideal conditions, we would get 2.54 grams of copper. Now, I don't know what you got, and I honestly don't remember what I got when I did the reaction, so I just picked a number for our actual yield. Say, for argument's sake, that when we did the reaction, we isolated the copper, we decanted, we dried it, all of that, we massed 1.73 grams of copper. So it's not our theoretical yield, so this would be our actual yield. If we want to calculate percent yield, we do 1.73, so that's our actual, divided by our theoretical, which is 2.54, times 100, and we get 68.1%. Pretty good percent yield. Your percent yield when you actually did the reaction might have been a little bit higher. This is one of those reactions that works really well under just normal everyday conditions. If you get a lower percent yield, especially if you're down in the 20s and 30s, you need to start thinking back about your experiment. What happened to get that low of a percent yield? In this case, we decanted. Decanting means there's the potential to lose solid. Maybe you lost more copper than you originally produced. So by the time you got to your final mass, you had less copper in there than was originally created. There could be any number of problems, well, not problems, errors that could have occurred, some that we can control and some that we can't. But percent yield helps us look at how well the experiment went and what some of those errors might have been.